Of all the energy that is used around the world, nearly a third is consumed by the building sector. In large cities, 80% of carbon emissions can come from energy used to heat, cool, and power buildings. Over the next few decades, the amount of energy used by the building sector will increase dramatically, and so will the amount of related emissions. In high-growth regions, buildings' energy use will increase by 2050. So improving the energy efficiency of buildings is vital for reducing greenhouse gas emissions. Products that depend on chemistry can enable significant reductions in energy use and greenhouse gas emissions in the building sector. For example, energy-saving products installed in homes in the United States prevented nearly 252 million tons of CO2 emissions in 2010. Studies show that if this trend continues, more than 7 billion tons of emissions can be avoided by 2050 in the US alone. And in the European Union, energy-efficient building products could create emission savings in homes of more than 13 billion tons by 2050. In Japan, more than 450 million tons of emission savings in homes is achievable in the same time frame. The global chemical industry is working on a roadmap to meet these ambitious goals. This roadmap will help chemical companies and policymakers work together to help ensure these savings are realized by 2050. So the chemicals industry not only provides the products and technologies to reduce greenhouse gas emissions today, it is also working on solutions for even more energy-efficient buildings tomorrow.
You wouldn't put up with a dripping faucet in your house for very long, so why put up with the same thing happening with your home's energy? If you're like most people, you've got lots of little energy drips happening all over your house, which together can add up to a lot of energy and money being wasted. Take these for instance. Incandescent bulbs are the cause of a big energy drip that can easily be fixed by replacing them with these guys, which use up to 75% less electricity and last 7 to 10 times longer. Replace the 5 most used bulbs in your house with CFLs, and that adds up to a savings of $25 each year. And how about all these red lights? They show that these devices are still using electricity even though they're turned off. That's another energy drip that costs our nation over $4 billion a year in wasted electricity. Put those electronic devices on a power strip and cut the power when not in use. 75% of the energy used by your computer happens when there's no one in front of it. How's that for an energy drip? Properly setting your computer's power management could save you about $33 a year. Using a programmable thermostat is another great way to lower your energy costs. Just set it and forget it for a cozy home with lower monthly bills. If your house isn't properly air sealed, that's a huge energy drip, and it's probably the cause of those dreaded ice dams on your roof. Keep that air inside where it belongs by sealing leaks going into your attic and properly insulating. You'll increase your home's comfort and save a bundle. That ancient appliance? Talk about an energy drip. If it's old enough to vote, it's time to think about replacing it with an energy-efficient model that can actually save you money in the long run. Fixing these energy drips in your home could save you about $575 per year. Multiply that by the number of houses in your neighborhood, by the number of neighborhoods in your town, by the number of, well, you get the idea. Keep your money where it belongs. Fix your energy drips and turn the sound of into. Help your friends and family save money too by sharing this video with them. Send them an email, tweet about it, or post it on Facebook. Then head on over to MinnesotaEnergyChallenge.org and join tens of thousands of your fellow Minnesotans who have pledged to save millions of dollars by making energy upgrades.
The most popular Eagle Sun system, called a drainback system, can be used in any climate and requires no maintenance. Heat from the sun is collected by the solar panels mounted on the roof. The heat transfer fluid, usually water in a drainback system, is pushed by a circulation pump up to the collector, where it is heated as it moves upward through copper tubes in the collector. Once heated, the fluid exits the collector and circulates down to the drainback reservoir. The drainback system is an indirect system, meaning that the fluid circulating through the solar loop never comes into direct contact with usable household water. Heat is transferred to the main water line using a heat exchanger, and it is then stored in the tank and made available for use. An Eagle Sun system will allow you access to enough hot water to wash your dishes, do your laundry, and enjoy hot showers for free all year long. To calculate your own personal savings, click the Solar Savings Estimator link located on any page.